welcome back, guys. This is IT Basics for you. Thank you for signing to our channel. Today we have a very interesting topic for you, which is around large language models. It's in boom, it's in demand everywhere. People are talking about large language models. ChatGPT 3, ChatGPT 4 all uses the large language models in the back end. So does some of the products from Microsoft and Google as well. Today we will be covering one specific topic which will enhance the overall capabilities around large language models and will empower you to use your own data along with large language models and provide domain specific responses solutions to your own operations. So let's get into it. So today the key topics that we are going to cover through this video, this would include understanding the large language model, a very basic overview, and what are some of the industry challenges around large language models. Then we'll cover up for what exactly is grounding, what is the concept. We'll go to basics understanding about how do we use grounding, how does it work, what is the base operation that we need to do before the grounding actually gets enabled, and how do we use it for our own operations. We'll then see a use case around grounding, and finally coming down to benefits of grounding. So this video you will also get to know how grounding is becoming more and more popular, more importance is given to grounding for your own organizations, your own operations. So we'll get to see what are those benefits around grounding. All right, so let's understand what is a large language model before we really go to what are some of the industry challenges with large language model, right? So I'm sure most of the audience is already aware of it, but let's take a basic check on that, right? A language model is a machine learning model, that aims to predict and generate credible languages. They generate probabilities, and how do they learn it? They learn through the large structured text, structured data which you provide to these models, right? So it generates probabilities by learning from those large structured text and data. For example, the very basic example that you might find in your day-to-day life is when you're working on Microsoft Word, you will find there is an autocomplete functionality. That's one of the basic language model, which is embedded into Microsoft Word, Microsoft applications. Now, beyond this, historically, the large language models, have been dependent upon n-gram models, and more recently, these have become more like a sophisticated neural language models with billions of parameters, trainings done on that big set of data and unlabeled data, I would say, and still meeting your requirements on what is available generically in the industry as a data, and your language models trained on that, and it's giving you an output basis, the learnings from that industry-wide data. Now these models have been growing bigger and bigger, and their complexity and efficacy has increased over a period of time. Early language models, they probably could predict the probability of a single word, and they were small. But the modern language models, the large language models, they can go beyond predicting a single word. They can predict a probability of your sentences, paragraphs, and even the entire documents, right? So definitely they are going bigger and bigger with a lot of these parameters. Those are built around it, and they are trained on it. Now, talking about the challenges of these large language models, the very basic has been the knowledge. Everybody knows, hey, the large language models are built upon uh, the information, the data which is publicly available, and they have been trained on their data set over a period of time till a certain time, right? So I think some models like ChatGPT and all, they have been trained on the data set which was publicly available, say by 2021 September, and then the recent release GPT-4 has been trained again on certain time period till certain time period. So this doesn't hold the most recent publicly available data. They are not updated continuously. They are updated on the data set which has been available for a certain period of time. So that's one of the challenge. Second, hallucination. That's another one of the challenge with the large language models, which means uh, you are getting a response from these models which seems to be correct, but it contains false information, right? So that can happen. That happens a lot with these language models. Prominent large language models like Bard and ChatGPT show how the state of the art language models are susceptible to generating misinformation, right? They're not away from that. They have also been generating some misinformations, right? And that's what we refer to as hallucination. There has been a recent example about it in 2023 where Google large language model Bard incorrectly claimed about planetary discoveries, right? This goes back into February 2023 when this model was launched to compete with ChatGPT. I mean, everybody wanted to win in that race, right? And Google was nothing new. They launched that model at that point of time. However, when they launched it, they made wrong headlines because of a factual error in their responses. When people asked, hey, what new discoveries from the James Webb Space Telescope uh, that I can tell my people about, Bard claimed that telescope had snapped first ever images. It snapped images of a planet outside our solar system. However, you'll be surprised, the claim was incorrect. It was incorrect information. That's what hallucination is all about. They, the other challenge is, as I mentioned, they have access only to public data. They lack knowledge about anything that resides within your organization, into your own systems, like human resource systems, financial systems, your knowledge base, quality systems, so on. So it doesn't have linkages into those data sets. So whatever information it provides is limited to what data is available publicly. These are definitely expensive, right? It takes months and months to train the models on new set of data. So you can't every now and then run these models on huge set of data and expect the output to be available immediately to you. So it's pretty expensive from resources standpoint and effort standpoint. So now understanding these challenges, the big question that comes to anybody who is serving a big organization, a corporate, running their own functions, they definitely would like to start thinking, hey, how I can use LLM into my organization? How can I train my models to use my own data and be domain specific, whether it's banking, healthcare, manufacturing, whatever domain it is. How can I train it or how can I use it against my own set of data around my own domain and be very specific so that my people in my organization can write queries to my domain, my data, and they get an output which is specific to my own systems, my own organization. So that's where the industry is heading. That's what people would like to do, and utilize these models against their own domain specific data. Okay, so the first question that comes to our mind is, hey, what is grounding? What exactly is it? So if we go with the definitions in the industry, grounding is nothing but a process of using your large language models with the information which is use case specific, which is more relevant to you, which is not available, as part of the public information through which the large language models have been trained. So any data which is your data, which is specific to your organization, which is not publicly available, uh, on which large language models have not been trained, but now you want to use that data along with large language model and be domain specific, put your queries and get your responses very specific to your domain. That's where the grounding principle comes into play. We all understand large language models come with lot of knowledge base, but that knowledge is limited. It's not tailored specific to your use cases. So to obtain accurate and relevant output, your organization specific output, you must provide LLMs with the necessary information. In other words, you are grounding the models in the context of your specific use case. So let's go further into details around grounding. Okay, so now we have some bit of understanding on LLM and grounding, right? So let's get to the point where we, get a little bit more understanding about what are the techniques of grounding. For this video, we'll be focusing on one of the techniques, and I'm sure there are multiple techniques in the industry, but for this video, we are going to be specifically talking about a technique called RAG. RAG stands for Retrieval Augmented Generation. This is one of the techniques for grounding, and it's a process for retrieving the information relevant to your query, relevant to your instruction. That's what it does. It provides this task to the language models with a prompt and a query, and then the model uses all that specific information to generate responses for you. So let's try to understand that with this schematic. If you look here on this flow, what happens exactly in RAG is you use certain applications. These could be Microsoft applications. This could be a query engine. Any triggering mechanism. Your user triggers a query. It can be a chatbot also, right? Your user triggers a query or an instruction, right? And then it goes back to the next step, which is a retrieval function. The job of the retrieval function is to use that trigger, use that query or instruction, and then hit your data sources, the data sources which exist within your organization, within your organization's boundary walls, right? Uh, this can be through a database, it could be through your files, it could be your SharePoint files, it could be your API calls, whatever it is. So you get plugged into your data sources. That's what the retrieval function would do. Once it has collected enough data, then it goes back into the LLM context section, right, which is where it passes on the query and the prompts and the data, which is all merged in that context window of LLM. And then there is a good amount of space or left in that context window so that it can get the responses stored into the context window. The LLM, when it has all this information, which is your query, your data, your prompts, what it does is it makes a LLM call. It makes an LLM call and then generates an output based on the data that you have provided. It doesn't capture any data that you have provided to the LLM model, but it uses the model capabilities to generate an output based on your data, and then the output that it generates or yields are much more impressive results, much more domain specific results, very precise to your organization, and then it provides that output back to you, which can be consumed by your applications, your users, as and when it happens. So that's exactly what the grounding technique does. We spoke about RAG, as I said, but definitely, guys, there can be multiple other techniques in the market which will help you to perform the same actions. While we spoke about grounding, we should also be aware of certain other elements of it. One of them is semantic search. It's not a new concept in the industry, but RAG specifically uses semantic search. It's a primary technique for RAG. Uh, the process involves indexing the documents or the fragments of the documents based on which semantic representation is created for the search of data, for output that needs to be generated. So semantic search is pretty important when you're feeding in your data back into the LLM models. There are other techniques such as vendor indexing and retrieval, which is also available, where the information received from the large language models is influenced further by pre-processing or by chunking strategies, right? For those who are aware of vector indexing, I'm sure you must be aware of various tools that exist in the market for same, right? Such as LangChain, which is available in Python and JavaScript library. Or you also know about Llama Index, which is again a Python library specifically designed for vector index retrieval. So you can think about feeding your data back into RAG through any of these approaches, which is either semantic search, or you can also use vector indexing and retrieval mechanisms. So that's pretty much how you typically go and extract relevant outputs using LLM models. So I wanted to give you one example about grounding. This is an available demo which is existing on aidemos.dev site, right? You can very well log in to that portal. You can go through this search that they have created, and this entire search is based on external data source, which is a very specific to a domain, right? So the data that they have used is a Stack Overflow, and everybody knows like why Stack Overflow is being used. You post your issues, your troubles, you get responses. So what has been done through this demo, they have linked their findings back to this data source of Stack Overflow. In this example, they have an option to search by entering any coding question, right? You can enter any coding related question pertaining to databases, pertaining to the programming languages, pertaining to other technologies, right? And once you post those queries, it runs a text search on the back end on 8-9 million questions which are already available on Stack Overflow. So in this example, LLM doesn't have to memorize the 8 million, 9 million items which are available in Stack Overflow and become more complex or lengthy. But the Stack Overflow dataset is just attached to the model as an external source, right? As an external data source. And then they specifically use vector search to respond back with relevant content against those queries to the users. The outputs are all directly grounded to the business facts, right? Because it's using a very specific data set which have historical data about questions and answers, right? And that's what ensures that the output is pretty grounded to those business facts. It is crucial for ensuring what you get as an output, like a quality result, more accurate result, and more relevant output against your queries. Now, basis this, you can definitely go and search this on this portal, and then perform your own searches, and then I'm sure you get a lot of thoughts like how can you go and use such a functionality in your own organization for your own people to serve them for maybe understanding about organization policies. They don't have to go and search multiple sites. They can just write a query, and then if your data set has already included all the policies, procedures pertaining to different functions in an organization, then it can give very specific results, very specific output to your end users, to your employee in the organization, and that definitely saves a lot of time and give good overall employee experience as well. Okay, so that was the whole objective of the video. We wanted to give you a high level overview about large language model, grounding, challenges of large language models, and then finally the technique for grounding and how it is being used in the industry. I'm sure with this video you should be able to now start thinking how to utilize such technology within your own organizations. Okay, so this brings us to the end of this video. Hope you liked it. For more such videos, please subscribe to our channel, and you can continuously watch more videos which are coming up on this channel. Thank you very much for your time, guys.